So in first part we are learn about the total brief discussion about the column. Okay, now if the condition are both hinge, so we get the L effective equals to L. Okay, this is a term we are used. Now when both end are fixed, then effective length is taken as half of that portion. Okay, L effective taken as L by 2 when both are fixed when both hinge, L equals to L effective taken with fixed, L effective equals to L by 2 taken. When one end fixed and another end hinge, we are taking L effective equals to 1 upon root 2. We can write L effective equals to L effective as L to the base E. Okay. When one end fixed and another end free, we are taking L effective equals to twice L. Okay. This is when one end fixed and another is free. So this is a formula which are very important during solving the numericals. Okay, we are taking some numerical of this columns portion. We with the help of this L effective we can solve columns at very right conditions. Okay, now we are proceeding some such derivations which are helps for the solving out the how to get L effective, and we are solving the some this column as I told you that one end fixed, one end free, or both are hinge, both are free. So this is how this how this L effective is come occur and what are the boundary conditions we are applying in the column. We are discuss about that. Okay, now first we are discuss about the both end fixed, both end hinge. We are to only derive. We are only taking the three derivation today about the both end fixed hinge. Okay, so here both end fixed, both end sorry, what is this? Both ends hinged. Okay, now both end hinge. Diagrammatical representation of the column where it is both end fixed, it is given by here a hinge beam. We are drawing here a line. Okay, a straight line which representing the column. Okay, now here also a line. Okay, now we draw the bulking factor during applied. Sorry, here some force is applied. Without a force, we are applying a P force here from both the side, because without applied a force, there is no bulking is produces. Now here bulking is produced from this point to this point. Oh, sorry, it is getting wrong. Actually, this is my first lecture about on this whiteboard, so I have no practice. We are draw a section here which represent the movement along the point. We are taking movement at this point. Okay, so this distance I draw here. Okay, this distance is y, capital Y. The section is given by small x, and this distance from the section to the point we are getting name here point A and here point B, where both supports, and this portion I name as capital X, and all the column length, total column length is given by capital L. Okay, so okay, this is diagrammatical representation of the column where both end are fixed. Now here some consideration important to where whenever you solve this numerical, solve this derivation, write like as consider the column of length AB which is hinged at A and B, subjected to load P. Due to application of load P, the column is deflected as shown in figure. You show this deflection. Deflection is nothing but bulking. Okay. Consider a section XX at a distance of x distance. We are considering this XX section from this x distance. Okay. where the deflection is y. So that why the y is a deflection. You get my point? What I said exactly to you guys. Okay. Now we are proceeding toward the derivation. How solve the derivation? Okay. We are taking the moment at this point. Okay. What is the formula for taking a moment at any point? Force into perpendicular distance. Okay. So this is a force and this y is a perpendicular distance. So our movement is given by, we are taking m. Okay. We know that what is a that term is taking next topic. Okay. M equals to, we are taking a movement. So m equals to p. Now this portion is anti-clockwise, so it is getting a minus p, and what is the length? This is y. Okay, minus py. Now take this minus py at this side. So we are getting the equation minus p m plus py equals to 0. Now we know that the Euler's equation, in Euler's equation, m equals to ei into d2y by dx square. Okay, so we are putting this value in the position of em. So we get ei d2y by dx square plus py equals to 0. Now we are dividing the all term by ei. So we are getting ei get cancelled. So ei cancel. So we are getting here d2y by dx square plus py divided by ei is equals to 0. Okay, we are getting this equation. Now by solving this equation, we are getting, this is our equation number 1. I love this red color. Okay, so equation number 1. Now by solving this equation, okay, by total solving this equation, we are getting one equation. This equation is given by y equals to c1 into cos of in bracket x under root of p upon ei plus c2 sin of in bracket x under root of p upon ei. Okay, bracket complete. So we are getting this equation. I give this equation as name 2. Okay, now the term putting the boundary condition. Now we are applying some boundary condition. Now apply some boundary conditions. Boundary conditions. We get which type of boundary condition we are applying? We are applying put y equals to 0. Okay, this y equals to 0 and x equals to 0. Okay, we are putting y equals to 0 and x equals to 0 in equation number 2. Now by putting, we are putting a value of y is equals to 0 is equals to c1 into cos of 0 plus this total term is 0. Okay, so what is the cos of 0? Is to be 1. So c1 equals to 0. We are getting the value of c1 equals to 0. But now here some consideration, which is here c1 equals to 0, but c2 is not equals to 0. Here it is a consideration. Okay, after that we are putting the value. Okay, we are putting another. Okay, now it is first portion of our derivation. Okay, I just cross this portion. Okay, now again we are putting c1 equals to 0. We know that c1 equals to 0. Okay, in this equation, and y equals to obviously 0. So we are getting c1 is no 0, 0 equals to 0 plus c2. I know I put here, I consider here c2 is not equals to 0. So c2 sine of what? Sine of L under root of P upon EI. Okay. Now c2 is known, C2, the value of C2 we are getting here. So the equation is getting like that: C2 sine of L in bracket P upon EI is equals to 0. C2 going here, so it getting as 0, so it get cancelled. Okay, after all sine getting at that portion, the sine of consider, so it getting as L under root of P upon EI is equals to sine inverse of 0. What is the value of sine inverse of 0? The value of sine inverse of 0 is pi. Okay, so here getting some value, L equals L in bracket under root of P upon EI equals to pi. Now I manage this L at this side, so I get P upon EI under root, okay, pi upon L. Now I take under root, taking square at both the sides, so I get P upon EI is equals to pi square upon 4. Now P equals to pi square upon 4 into EI. Okay, sorry, this is not 4, this is L. Pi square upon L square, I just get confused. Okay, L square. Now this is the value getting during the solving this equation. So here L equals to L effective. Okay, that means whenever the condition is occur like that, the both end are hinged, so we are putting the value of L as a L effective as a L. Okay, so this is total equation. What we are done in this equation, we are first draw this diagram. Now we are taking the bending moment when the force of P applied on both the end of the column. Here some I draw some section XX, small xx. Distance between the column and this bending, maximum bending is given by y distance. The total column length is given by capital L, and the distance from the point B to the section is given by capital X. Now I take the moment at the point Y from the upward direction. It is anti-clockwise, so it getting as m equals to minus py. Now I get py is at this side, so m plus py equals to 0. We are know the value of the Euler's m equals to ei into d2y by dx square. So I put this value in the value of m. So I get the value ei equals to d2y by dx square plus py equals to 0. Now d2y by dx square plus py equals to 0. I divided this term by ei. After all, I get this value y equals to c1 cos of x under root of p upon ei plus c2 sin of x under root of p upon ei. Now I put some boundary condition wherever the y equals to 0 and x equals to 0. By applying this condition, I get the value of c1, but I consider the c2 is not equals to 0. Okay, when suppose I consider c2 is also 0, the both value are getting 0, I cannot get the value of p. Okay, whenever the both the end are fixed. So I consider c1 equals to 0, but c2 is not equals to 0. So I put this again value in this equation. X and y is already 0, but here x is considered as a L. Okay, now here I put this value, c2 is getting there, it getting 0, sine getting there, sine inverse of 0, it given by pi, then L is getting at this side under root of p upon ei equals to pi by L. I taking square root, so p upon ei equals to pi square upon L square, so p equals to I taking ei at this side, so pi square upon L square equals to L. So I can write this equation when the L effective equals to L, I will take L equals to L effective. The equation is like as p equals to pi square upon L square, L effective square into ei. Okay, so this is the formula for determining the for determination of the bulking factor when the both end are hinged. Okay, thank you for watching my tutorial.